All right, so picture this. It's 1948, a flat stretch of Iowa farmland. A young guy named Gary Vermeer, barely in his 20s, is standing in a field watching his father and a crew of hired hands wrestle with hay. They're using pitchforks. Pitchforks. In the middle of the 20th century, with tractors running all over the place, with combines harvesting grain, with machinery revolutionizing every other part of farming, and here they are, stabbing at loose hay like it's still 1850. Gary's watching this and he's annoyed. Not just annoyed, he's looking at this whole operation like some kind of medieval torture ritual that somehow survived into the modern age. Because that's what it was. Haying season was brutal, backbreaking, dangerous, and slow. Unbelievably slow. See, here's the thing about hay. You cut it, you let it dry, then you have to gather it up, load it onto a wagon, haul it to the barn, and stack it. Every step of that process in 1948 was still being done mostly by hand. Farmers would use wooden hay loaders, which were these rickety contraptions that would lift loose hay onto a wagon as a team of horses pulled it through the field. Or they'd just fork it up by hand. Either way, it was exhausting, time-consuming work that hadn't changed much in 100 years. Gary Vermeer looked at this problem and thought, there's got to be a better way. And not just a little better, a lot better. Like fundamentally different better. Now, Gary wasn't some college-educated engineer. He didn't have a degree in mechanical engineering. He'd grown up on a farm near Pella, Iowa. Pella, if you don't know it, is a small Dutch-American town in the middle of the state. Settled by Dutch immigrants in the 1840s, it was a tight-knit community where people worked hard, went to church, and didn't waste time on things that didn't need doing. Gary's father, Ralph Vermeer, ran a small farm equipment repair shop. Ralph was good with his hands, good at fixing things, and Gary grew up around machinery. He learned how to weld, how to work metal, how to look at a broken machine and figure out what was wrong with it. But more than that, he learned to look at machines and think about how they could be better. Not just fixed, better. By the time Gary was in his early 20s, he'd already started tinkering. Small projects at first, improvements to existing equipment, little modifications that made things work smoother, faster, easier. But the hay problem, that was bigger. That was something that needed a completely new approach. So Gary started thinking. And the more he thought about it, the more he realized that the entire process of handling hay was wrong. Not just inefficient, wrong. Loose hay was a nightmare to work with. It was bulky, it was awkward, it took up massive amounts of space and required constant manual labor to move and store. What if you didn't have to deal with loose hay at all? What if you could compress it, package it into something dense, something you could handle mechanically, something that could be stacked and moved without needing a crew of workers with pitchforks? Bales. That was the answer. Bales. Now, the idea of baling hay wasn't new. There were already machines that could compress hay into bales, but they were huge, expensive, stationary machines. You'd have to bring the hay to the baler. They were powered by belt-driven systems connected to a tractor or a stationary engine, and they were slow, really slow. And they required multiple people to operate. One person to feed the hay into the machine, another to tie the bales, another to stack them. Gary thought, what if you could make a machine that moved through the field? What if it could pick up the hay, compress it, tie it, and drop finished bales right there, ready to be collected? A machine that did the whole job, start to finish, with just one person driving the tractor. In 1948, he built his first prototype. It was rough, really rough, cobbled together in his father's shop with scrap metal, salvaged parts, and a lot of trial and error. It didn't work perfectly. In fact, it didn't work well at all at first, but it worked enough to prove the concept. The machine had a pickup mechanism, a set of tines that would lift hay off the ground as the machine moved forward. The hay would be fed into a compression chamber where a plunger would ram it into a tight rectangular block. Then, and this was the tricky part, a knotting mechanism would wrap twine around the bale and tie it off. The finished bale would be ejected out the back and the machine would keep moving, picking up more hay, making another bale. It sounds simple when you describe it like that, but making it actually work, that was a nightmare. The knotting mechanism alone was incredibly complex. You're trying to get a machine to tie a knot automatically while moving in a dusty, dirty, vibrating environment. The timing had to be perfect. The twine had to be fed at exactly the right tension. The knot had to hold every single time, or the bale would fall apart. Gary spent months refining the design, testing it, breaking it, fixing it, testing it again, and slowly it started to work. Not just work well. By 1949, he'd built a machine that could actually do what he'd set out to do. A pole-type hay baler that could be towed behind a tractor, that could pick up windrows of hay and turn them into compact tied bales, one after another as fast as the tractor could move. He called it the Vermeer Model A, and it was about to change everything.
So Gary's got this baler. It works. It actually works. And farmers lose their minds over it. You have to understand what this meant. For centuries, hay had been the single most labor-intensive part of farming. You needed it to feed livestock through the winter. You couldn't skip it. You couldn't cut corners. And it took an enormous amount of time and manpower. A typical farm in the 1940s might spend weeks on haying. Entire families would be out in the fields. Hired hands would come in during haying season just to help get the crop in before it rained and ruined everything. And now, Gary Vermeer shows up with a machine that lets one person driving a tractor do the work of a whole crew. And not just do it faster, cleaner, and with bales that were easier to handle, easier to store, and easier to transport. The A1 wasn't perfect. Early versions had problems. The knotters would jam. The pickup mechanism would clog if the hay was too green or too dry. The compression chamber would sometimes crack under the strain. But Gary didn't walk away from those problems. He fixed them, one by one. He'd go out to farms, talk to the guys using his balers, find out what was breaking, what was annoying them, and he'd go back to his shop and redesign that part. By the early 1950s, Vermeer balers were spreading across Iowa, then across the Midwest, then across the country. Farmers who saw one in action wanted one, and Gary, working out of a small shop in Pella with a handful of employees, was suddenly running a manufacturing operation. But here's where things get interesting, because Gary Vermeer wasn't content to just make balers. He was looking at farming, at construction, at industrial work, and he was seeing problems everywhere. Problems that needed machines that didn't exist yet. In 1955, he built something new, a straw blower. Now, this might not sound exciting, but stay with me. Livestock barns needed bedding. Straw makes good bedding. But getting straw into a barn, especially into the loft areas, was a pain. You'd have to carry bales up ladders, break them open, spread the straw around. Gary thought, what if you could just blow it in? He designed a machine that would take a bale of straw, break it apart, and use a powerful fan to blow the loose straw through a long tube, like a fire hose, right into the barn. You could aim it. You could fill a loft in minutes instead of hours. Farmers loved it. Another problem solved. Another machine that didn't exist before Gary built it. Then, in the 1960s, he started looking at a completely different problem: tree stumps. If you were clearing land, if you were a contractor working on a construction site, or a farmer trying to expand a field, tree stumps were a nightmare. You'd have to dig around them, chop through the roots, use chains and tractors to try to pull them out. It took forever. It was dangerous, and half the time, the stump would win. Gary designed a machine called a tree spade. It was a mechanical device with 4 curved blades that would dig down around a tree, cut through the roots in one smooth motion, and lift the entire tree, root ball and all, out of the ground. You could transplant large trees without killing them. You could clear stumps without spending days on a single stump. But he didn't stop there. In the late 1960s, he invented something that would become one of his most important contributions to the construction industry: the trencher. Now, trenchers existed before Gary, but they were big, heavy, expensive machines designed for utility companies. If you needed to dig a trench for a water line, a sewer pipe, or an electrical cable, you either hired a crew to dig hand, or you rented a massive piece of equipment that cost a fortune and required a skilled operator. Gary looked at that and thought, what if you could make a trencher that was small, affordable, and simple enough that a contractor could own one and operate it themselves? He designed a compact walk-behind trencher that used a chain with cutting teeth, like a giant chainsaw, mounted vertically. It would dig a narrow, precise trench, fast, without tearing up the surrounding ground. Contractors went crazy for it. Suddenly, jobs that used to take days could be done in hours, and the machine was affordable enough that small contractors, not just big utility companies, could buy one. But Gary wasn't done. Not even close. In 1972, he invented something that would change underground construction forever: the horizontal directional drill. This one's kind of brilliant. See, up until the 1970s, if you needed to run a pipe or a cable under a road, under a river, under a building, you had two options. You could dig a trench, which was expensive, disruptive, and sometimes impossible, or you could use a method called auger boring, which was slow, limited in distance, and required perfectly straight drilling. Gary thought, what if you could drill horizontally underground and steer the drill as you go? Not just drill straight, actually steer it, curve it, guide it to come up exactly where you wanted on the other side of whatever obstacle you were trying to cross. He designed a machine with a drill head that was slightly angled. As it drilled forward, it would naturally curve in the direction of the angle, but if you rotated the entire drill string, the curve would average out and the drill would go straight. So, by controlling the rotation, you could steer the drill. Left, right, up, down. You could drill under a highway, under a river, under a railroad track, without ever disturbing the surface. The first horizontal directional drill Gary built was crude. It was small. It could only drill short distances. But it worked, and it proved the concept. By the late 1970s, Vermeer was manufacturing larger, more powerful models, and by the 1980s, horizontal directional drilling was revolutionizing the utility industry. Today, almost every underground utility line, every fiber optic cable, every gas line, every water pipe that crosses under a road or a river was installed using a horizontal directional drill. And the entire technology traces back to Gary Vermeer working in a shop in Pella, Iowa, trying to solve a problem that everyone else thought was unsolvable.
So by the 1980s, Vermeer manufacturing is, well, it's a giant. They're selling equipment all over the world. Balers, trenchers, tree equipment, directional drills, thousands of machines rolling out of the factory in Pella every year. And Gary Vermeer is still running the company, still designing, still tinkering. But here's the thing about Gary. He never acted like a tycoon. He didn't move to New York. He didn't build a mansion. He stayed in Pella. He went to the same church he'd always gone to. He worked in the same shop alongside the same people, solving the same kinds of problems he'd been solving since he was a kid. There's a story, probably apocryphal, but it feels true, that in the 1980s, a delegation of Japanese engineers visited the Vermeer factory. They wanted to see the horizontal directional drills, wanted to understand the technology, maybe license it. They were expecting a corporate tour, executive presentations, the whole show. Instead, Gary walked them around the shop himself, in work boots, in a shop coat. He showed the machines, explained how they worked, answered their questions. At one point, one of the engineers asked if they could meet the president of the company. Gary said, "You're talking to him." That was Gary. No pretense, no corporate nonsense. Just a guy who liked building things that worked. And he didn't just invent machines, he invented systems. He thought about how machines fit into the real world, how they'd be used in the field, how they'd be maintained, how farmers and contractors who weren't engineers would operate them. Take the hay baler. Gary didn't just build a machine that compressed hay, he designed it so that the knotters could be serviced without tools, so that the pickup mechanism could be adjusted on the fly, so that if something broke, a farmer could fix it themselves in the field without calling a mechanic. Or the directional drill. Gary didn't just invent a machine that could drill horizontally. He designed a system where the operator could track the drill head underground, could see its position in real time, could adjust the angle and direction without stopping the drill. He built the controls to be intuitive, so that an operator who'd never used one before could figure it out in a day. This philosophy, this obsession with making machines that were practical, that were usable, that solved real problems in the real world, it became the foundation of Vermeer manufacturing. And it's why the company survived and grew while so many other agricultural equipment manufacturers collapsed or got bought out. By the 1990s, Gary had stepped back from day-to-day operations. His children were running the company, but he was still around, still inventing, still tinkering. In 1996, at the age of 72, he designed a new type of forage harvester, a machine that could chop silage faster and cleaner than anything on the market. He didn't need to do that. He was already successful. He was already respected. But that wasn't the point. The point was the problem. The point was figuring out how to make something better. Gary Vermeer passed away in 2008,
at the age of 83. By then, Vermeer manufacturing employed thousands of people. Their machines were used in over 100 countries. The horizontal directional drill had become an entire industry. The hay baler, the machine he'd built in his father's shop in 1948, was still being manufactured, still being sold, still doing the work he'd designed it to do 60 years earlier. But here's what I think is the most important part of Gary's story. He wasn't trying to build an empire. He wasn't trying to get rich. He wasn't trying to be famous. He was just annoyed. Annoyed that things didn't work the way they should. Annoyed that people were wasting time and effort on problems that could be solved. And so he solved them, one machine at a time, one problem at a time. And in doing so, he changed farming, construction, and utility work forever. There's a particular brilliance to what Gary did that goes beyond just inventing machines. He understood modularity before most people even had a word for it. Vermeer equipment was designed so that parts could be swapped, upgraded, replaced. A baler from the 1960s could use some of the same components as a baler from the 1980s. A trencher could be fitted with different cutting chains depending on the soil conditions. A directional drill could be upgraded with better tracking systems without replacing the entire machine. This wasn't just good engineering, it was good economics. Farmers and contractors didn't have to throw away a machine when a better model came out. They could upgrade, they could adapt, they could keep using equipment for decades, which made Vermeer machines a better investment than competitors who built machines that were obsolete in 5 years. And Gary understood something else. He understood that the best machines were the ones that made the operator's life easier, not just more productive, easier. Less stressful, less dangerous, less exhausting. The controls on a Vermeer trencher were designed so that you didn't have to think about them. You just operated. The feedback was immediate. The machine did what you expected it to do. There was no guesswork, no fighting with the equipment. It just worked. This might sound like a small thing, but it's not. Operating heavy machinery is hard, it's physically demanding, it's mentally exhausting, and if the machine fights you every step of the way, if you have to constantly compensate for bad design, it wears you down. Gary's machines didn't fight you, they worked with you.
Now, here's where the story gets, well, not darker, but more complicated. Because Gary Vermeer's inventions didn't just make life easier for farmers and contractors, they also made modern infrastructure possible. Think about it. Every time you use the internet, every time you turn on a faucet, every time you flush a toilet, you're relying on underground infrastructure. Pipes, cables, sewer lines, water mains, fiber optics. All of that stuff is underground, and a huge percentage of it, maybe most of it, was installed using horizontal directional drilling technology that Gary Vermeer invented. Before directional drilling, running utilities under obstacles was a nightmare. You'd have to dig open trenches, which meant tearing up roads, ripping through yards, disrupting traffic, and costing enormous amounts of money. In dense urban areas, it was sometimes just impossible. You couldn't dig a trench through downtown without shutting down entire blocks for weeks. Directional drilling changed that. Suddenly, you could run a line under a highway in a day. You could cross a river without building a bridge or digging up the riverbed. You could install fiber optic cable through a neighborhood without destroying lawns and driveways. The telecommunications boom of the 1990s, the expansion of the internet, the rollout of cable television, all of that was possible because of directional drilling. Thousands of miles of fiber optic cable installed without ever breaking the surface. But it's not just telecom. Water systems, sewer systems, natural gas lines, electrical conduits, all of it. Every city, every suburb, every rural community relies on underground utilities, and those utilities are there because machines that trace back to Gary Vermeer's original design made it possible to install them efficiently. This is the kind of impact that's invisible until you think about it. Gary didn't just build machines, he built the foundation of modern infrastructure. And the same thing applies to his hay baler, modern livestock farming, modern dairy operations, modern horse breeding. All of it relies on baled hay. You can't efficiently store and transport hay without baling it. You can't feed large numbers of animals year-round without baled hay. And while there are lots of baler manufacturers, now they're all building machines that work on principles Gary Vermeer pioneered. So here's the uncomfortable truth. Gary Vermeer's inventions made the modern world work. Not in a flashy, obvious way, not in a way that gets him in history books or gets statues built in his honor, but in a quiet, fundamental way. The pipes under your street, the cables bringing internet to your house, the hay feeding livestock that becomes the meat on your plate, all of that exists because Gary Vermeer looked at problems and refused to accept that they couldn't be solved. Now, Vermeer manufacturing today is still family-owned, still headquartered in Pella, Iowa, still building equipment using the same design philosophy Gary established. They make balers, trenchers, chippers, stump grinders, horizontal directional drills, and more. They employ thousands of people. They sell equipment in over 100 countries. But they're not a household name. Most people have never heard of Gary Vermeer. If you mention him to someone who doesn't work in farming or construction, they'll give you a blank stare. And that's kind of fitting, actually. Because Gary wasn't trying to be famous. He was trying to solve problems. There's a particular genius to that kind of work, the kind of genius that doesn't need recognition, that doesn't need awards or accolades, that just works, that builds something useful, something that makes life easier, something that lasts. Gary Vermeer built machines that are still working today, 75 years after he built his first hay baler. Machines that are still being manufactured, still being sold, still being used. And not just used, essential. That's a legacy that matters more than any trophy or title. It's the legacy of actually making the world better. One machine at a time, one problem at a time. And it's a legacy that will continue long after anyone remembers Gary's name.
So what do we take from all this? What's the lesson here? Because there is one, and it's not the one you might expect. See, when people talk about inventors, they usually focus on the breakthrough moment, the eureka, the flash of genius, the single brilliant idea that changes everything. But that's not how Gary Vermeer worked. Gary didn't have one brilliant idea. He had 100 small ideas, 1,000 incremental improvements, a lifetime of looking at problems, thinking about them, and figuring out how to fix them. The hay baler didn't spring fully formed from his mind. It was a series of prototypes, each one a little better than the last. The horizontal directional drill didn't work perfectly the first time. It took years of refinement, of testing, of failure and adjustment before it became the revolutionary technology it is today. And that's the real story here. Not the genius inventor who changes the world with one stroke of brilliance, but the persistent problem solver who refuses to give up, who looks at a broken system and doesn't just complain about it, who builds something better, who keeps building, keeps improving, keeps pushing forward. Gary Vermeer could have stopped after the baler. He'd already succeeded. He'd already made his mark. But he didn't stop. He kept looking for problems, kept inventing, kept building, because that's what he did. That's who he was. And the world is better for it, in ways most people will never see, in ways that are invisible because they work so well. The infrastructure under your feet, the food on your table, the internet connection bringing this story to you. All of it, in some small way, traces back to a guy in Iowa who looked at a field of loose hay and thought, there's gotta be a better way. That's the legacy of Gary Vermeer. Not a single invention, not a famous name, but a philosophy, a way of looking at the world, a refusal to accept that problems can't be solved. And that philosophy is still alive today, in the company he built, in the machines still carrying his name, in the thousands of farmers, contractors, and utility workers using Vermeer equipment every single day. They might not know Gary's story, they might not know where the technology came from, but they're living proof that his work mattered, that his inventions made a difference, that solving problems one at a time can change the world. So the next time you see a construction crew working on the side of the road, drilling under the pavement without tearing anything up, that's Gary Vermeer's work. The next time you drive past a farm and see neat rows of baled hay in a field, that's Gary Vermeer's work. The next time you pick up your phone, connect to the internet, and access the entire sum of human knowledge in seconds, somewhere buried underground is a fiber optic cable that was installed using technology Gary Vermeer invented. And that, more than any award, more than any recognition, more than any fame, That's what matters. That's the measure of a life well spent, building things that work, solving problems that need solving, making the world, in quiet, invisible ways, a little bit better than it was before. Gary Vermeer did that, and the world kept turning, kept building, kept growing because of the machines he built and the problems he solved. That's the story. That's the legacy, and it's still being written every single day, in fields and construction sites and utility trenches all over the world.